Hi folks, this is a solution for number 3 for the Unit 5 extra review question. So we're given this equation here and they want us to solve this for x in 0 to 2 pi. Okay, so I notice here that I've got a quadratic trigonometric equation, except there's no middle term, like there's no tan 2x term. So I can actually just solve for tan x directly. Okay, so let's start by bringing the 3 to the other side. Okay, and now I can just take the square root of both sides of the equation. But of course I have to remember that when I take a square root, I have the possibility of the positive and negative square root. So here I have that tan 2x is either equal to positive or negative root 3. And I recognize this as being one of my special tan values. Okay, so remember that tan is y over x. Okay, so root 3, I should be thinking of my either pi over 6 or pi over 3 triangle. Okay, but since I need the y value to be the root 3, it's going to be the one with the bigger angle. So root 3 and 1. Okay, so my special angle that I'm working with is pi over 3. Okay, so I'm going to solve this problem purely by using my knowledge of special triangles at this point here. Okay, so I know that for positive root 3, well, I can take my angle in the first quadrant, okay, pi over 3, okay, and I know that because tangent has that property that it repeats every pi, okay, also in the third quadrant, okay, I don't have to split it up into two sets of answers, okay. So here I've got that 2x can be equal to pi over 3, okay, or 2x. When is it equal to negative root 3? Well, I can take the second quadrant, okay, 2 pi over 3. Because here I'm going to get root 3 over negative 1. And again, as before, I know that this repeats itself every pi unit. So I actually don't need that second answer to help me figure out all the answers here. So here, 2x can also equal 2 pi over 3. Okay, so now let's solve for x. So x pi over 6, bringing over the 2, and here x can be equal to 2 pi over 6, which is just equal to pi over 3. Okay, so these are my two possible answers, and now I can generate all the other answers by just adding the period of that trig ratio. But again, remember, the period of tan x is not 2 pi, it's pi. Okay, so the period of tan 2x is going to be pi over 2. Okay, so it's just a matter of adding pi over 2 to these here. So in this case, let me think of it as 3 pi over 6. Okay, so pi over 6 plus 3 pi over 6 is 4 pi over 6, which of course is just 2 pi over 3. Okay, sorry, that should be equal. Okay, let me add another 3 pi over 6, so that's 7 pi over 6. Let me add another 3 pi over 6, that's 10 pi over 6, which is just the same as divide by 2 is 5 pi over 3. Okay, but if I add another 3 pi over 6, 13 pi over 6, that's too large because I only want to go to 2 pi. Okay, so here are my answers. I've got pi over 6, 2 pi over 3, 7 pi over 6, 5 pi over 3. Okay, now let's work with this here. So again, instead of thinking, I guess I'll think of this again as 3 pi over 6, and I'll think of this as 2 pi over 6. Okay, so 2 pi over 6 plus 3 pi over 6 is 5 pi over 6. There's another answer. Okay, let's add another 3 pi over 6. That's going to be 8 pi over 6, but of course 8 pi over 6 is just the same as 4 pi over 3. And now let's add another 3 pi over 6. That's going to give me 11 pi over 6, which is still within my range. But if I were to add another 3 pi over 6, well, I'd be beyond the range of values that are allowed. So my answers from the second portion are these four here. So in the end, I've got 8 total answers which solve this equation. Okay, so just to recap, recognize here that you can solve directly for tan of 2x. Recognize also that when you take a square root, you have to consider the positive and negative. Okay, and then when you're solving for your angles, please be sure to remember that tan repeats itself more frequently. It repeats itself every pi units, and so here when we were looking at tan of 2x, that means it repeats itself every pi over 2.